a slot together reindeer head. So this is a simple 2D cutout job. We've just got 1, 2, 3, 4 parts and everything slots together to create this wall hanging reindeer head. So let's take a look at the project files.
So let's open up the reindeerhead.crv file, and in here you can see we have a series of vectors that represent various parts of the reindeer head. Now the file that we've got here will only work with 0.475 inch material. If you're using a different thickness in material, then you must ensure that you alter all of the slot widths to accommodate that of the material thickness that you plan to use. So if we just measure this area here from end to end, you can see I have a distance of 0.475, which matches that of my material thickness. So make sure you alter the slots if you're working with different material. Not only that, you also want to alter the fillets according to the radius of the tool that you plan to use. So how does the part fit together? Okay, so the antlers and the ears are going to slot into the head at the top there. So you'll notice that the slot for the head is actually double our material thickness, 0.95, because we're using 2 pieces that are going to slot in there. And then the bottom of the neck of our reindeer head is actually going to slot into this slot here, which sits within the actual deer mount shield itself. You can see I've included some circles here on the actual mount itself, and these circles are in place for the washers just to provide extra support to pull the deer into the mount, as the deer will ultimately be very top heavy. And then at the bottom left hand corner here we've got my test pieces, and as always with any slot together project you need to create some test slots to check the fit of the material within the slots themselves, and this little bit of extra cutout time will ultimately save us time and material in the long run, because we'll be able to get a correct match-up between the various allowances that will apply to each of these slots. Once we know which slot fits best, then we can apply that to our final part and just cut that out with no problems. So let's go and look at the toolpath. So I'll switch over to the toolpaths tab. So the first 6 toolpaths are all to do with our test pieces. So let's take a look at the first one as an example. So we'll just switch the visibility of that toolpath on. I'm also going to put the solid preview on, and we'll just zoom in on our test block there. Okay, so if we double click to go in there, so we're just pocketing these slots out, and with each one of these I have a piece, a rectangle, that should sit within each one of those slots, and we're just ultimately checking for the perfect fit with each one of these slot holes to ensure that we have a real nice fit for our final part. So the first one that we've got here, we've got pocket allowance of -0.005, so we're just overcutting past the vector by that amount. So you can see anything that's purple is what will be cut away, and you can see it's overcutting the original vector there. Okay, if we take a look at pocket test 01 over here, so -0.1, and if we just zoom in there you can see we're just overcutting that a little bit more than what we did previously. And then for the 0.15 it's a little bit more, and then for the last one we've got 0.2, so you can see how we're just stepping that up each time. Profile test, so that's to actually cut that out. Okay, so because I've moved that vector, let's just put that back in position somewhere around there, or we could just simply go ahead and double click on that just to recalculate that. So we're just cutting all the way through. We'll just tile the windows, and then again we'll just go ahead and look at that area. So this is our part being cut out there, and once we've got that cut out, we're then just going to apply a cutout for this area, so we can take that off our machine bed, de-tab our test piece that we can then insert into each one of these slots to check which slot has the best fit for when we come to machine the overall part out. So let's just maximise the 2D view, press F just to fit that to screen. We're just going to come out of the toolpath preview. And so once we know which allowance fit best, then we can apply that to our other cutouts. So we've got profile cutouts here, so this is for the antlers and for the ears. So in here we've got an allowance, so if we go in there, it turned out that negative 0.005 is what fit best to go onto our deer head. Okay, so just alter this according to the slot that fit best. Okay, we'll just close out of there. So you see I added tabs to all of the antlers and the ears where I felt was appropriate, just to ensure that it was held securely to my material block. Then we did some more profile cutouts. So here I've applied a cutout to the deer mount and the deer head. So this one has no form of negative allowance here. We don't need to apply allowance. We only need to apply the allowance to the slotting together parts, which is just the ears and the antlers. So again, I've added tabs to this, along with some ramps and leads, just to bring that tool in. Because I am using a compression cutter, we're just keeping that upward part of the tool away from the top surface, so bringing it down to a depth that ensures that we're going to be cutting down when we come to the sort of close to the actual edge of the vector. Let's close out of there. So then I have my pocket for my washer. So if we just double click in there, cutting down partially into the material to put my washers within that pocket. So if we just tile our windows, and if we just begin to preview all the visible toolpaths, see how the part looks so far. You can see I've got my pockets there, and then for the final toolpath, that is our slot that's going to go through the center of our mount. And again, we need to add in that allowance that we were happy with. So in there, you just want to alter the pocket allowance. You can see I've entered that negative 0.005 in there, and then we can calculate that. I'm going to cut through the material, that's okay, and then we'll just preview that toolpath, and this will be our finished part that we can then de-tab and then look at assembling. So important things to remember here is you need to alter the slot width according to the material thickness that you're using, and with that you want to make sure that you alter the fillet radius according to the tool that you're using, and I'm using a 1/4 inch end mill for all of my tool paths.
So with any slot together project, we must always do our test cut. So I've cut the test part of the file out. I've got my rectangle here, so this is going to represent anything that's going to slot into one of the slots, and then I have a series of slots here like you saw in the software just. So we've got negative 0.005, we've got negative 0.01, and then we're going up to negative 0.015, followed by negative 0.02. So it's always best to start with the larger allowance first and then work your way to the tightest fit. So I've got my part, so I've got it side on, and you can see straight away that is just sliding through there. So that's going to be pretty useless to us. So let's try the negative 0.15. Again, that is just sliding through there, not very practical. Let's try negative 0.01. Okay, so here it's not too bad. That's a nice fit, however it is a little bit loose. You can see that jiggling around in there. So let's go to our trusty negative 0.005 to see how that fits. And you can see we've got a real nice tight fit in there. Struggling just to push it out, but it does come out. So we're going to go and alter the file so that all of our profile passes has that allowance of negative 0.005. Okay, so we've got all of my parts fresh off the machine. I've gone round, I've detabbed everything, given it a nice sand so we've got a nice smooth edge for all the parts that form the reindeer head. So here we have the antlers, and then with the antlers we've got these ears. The two are going to come together something like this. So they're going to sit together here like so. And then both of these parts are going to slot into the top of our reindeer head at the top here. At the bottom of our reindeer head, or the neck of the reindeer head, is going to slot into the shield or the deer mount part of our reindeer head. And then on the back of our deer mount, you can see I have two circles, one at the top, one at the bottom. These have just been pocketed down just so I can put some washers in just to screw into the actual deer head part, just to pull it all in for extra measure so that the part doesn't fall out. So let's assemble the parts together. Okay, so I've secured the head of the deer to the deer mount using screws and washers in the back there. All we need to do now is put the ears in. So we're going to put the ears in at the top towards the back, followed by the antlers. They're going to go and sit in at the front. So you just need to make sure that we've got that in position. Just going to push it down a little bit. Make sure everything's in straight, and then give that a little push, and you can see we now have our final deer head. So that's ready for us to go ahead and hang on our wall. To top it off, we could give our deer head a little bit of Christmas cheer with these hanging baubles, and there is our finished part. So if you'd like to create your own version of the reindeer head, please head to Vectric.com where you could download the project file for the reindeer head that you can see here. And if you are going to cut your own, please share that with us using the hashtag #VectricFreeChristmas so we can see the variations that you've done of our free Christmas projects.